Good morning or afternoon, class. I'm not sure what time you'll be watching this video, but we started yesterday talking about ionic bonds, so now we're going to learn about covalent bonds, which is our second type of bond we're learning about this week. We have some more good videos that I'll link in our description. The same person describing our covalent bonding, and then another person describing how covalent bonds work. I will also be doing my own explanation to help you guys try to learn this. Oops, sorry, do not need those to be started yet. So I'll link those at a separate time so that you guys can watch them. But covalent bondings happens or are formed when atoms share electrons with one another. So when we talked about ionic bonds, what happened is the elements would each lose or gain an electron, and then because of their charges, be drawn to one another. But covalent bonds are a lot nicer. They share with one another. And we have two types of covalent bonds. We have covalent nonpolar bonds, which is when both elements have the same electronegativity. And remember, we learned even just yesterday in our ionic bonds that electronegativity means the measure of how much an element would want to pull an electron closer. And then we have covalent polar bonds as well. So when both elements have different electronegativities, there will be a polar bond. Think about water. So when we talked about nonpolar bonds, a lot of this happens between things of the same element. So sometimes our chloride will bond with another chloride atom, or different atoms will bond to themselves, so they would have the same electronegativity. Another very common one is carbon and hydrogen have a very similar electronegativity, so when they bond, it is nonpolar. But our polar bonds, like hydrogen and oxygen, have very different electronegativities. So these electrons in our water are going to be pulled just a little bit closer to our oxygen than to our hydrogen, and we'll explain that just a little bit more on our next slide. So, covalent bonding, we have polar covalent bonding. Electrons are pulled closer to one atom, making it more negative, which creates a partial negative charge. The atoms whose electron was pulled farther away has a partial positive charge. So, what I like to think about when I think of polar covalent bonding is almost like a tug of war, where we have a rope and two people pulling on it, but one person maybe is the size of a 5-year-old and the other person is an adult. So the adult will pull that rope closer to themselves than the 5-year-old can pull back. So, and that happens right here in the middle in our polar covalent bond. So chlorine's much larger, has a much higher electronegativity, so it will pull this electron. And since our electrons have a negative charge, it will make the chlorine have a partial negative. It's not like this ionic bond where this electron will move completely to chlorine and they will have a full negative charge. They still are sharing it, but it's just maybe taken more by the chlorine bond. Another important thing is when when the same element bonds together, it is known as a diatomic covalent bond. So, some of our common diatomic covalent bonds or covalent compounds are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So these would all be nonpolar because it's the same element. They have the same exact electronegativity. And we always write them as just H2. So when we usually write hydrogen, we just write an H, but since there's two of them, we have this little subscript, this little little number at the bottom. So anytime you see this, it's two of the same element together. Another important thing to learn are their characteristics of covalent bonds. So they are really bad conductors. So when we talk about metals, we say metals are good conductors because they'll let electricity and heat go through them, but our covalent bonds our covalent molecules are really bad about that. So we can use that to our advantage if we want to keep heat in one place, or maybe electricity we want to keep out of a certain area. We can fill the space with some covalent molecules to help that. For example, in my state, it gets really cold in the winter, so we have to have windows to keep us warm. And if we put some air, a covalent molecule like one of our diatomics, a common one, is a lot of oxygen and nitrogen in between two glass panes, two things of glass. It helps insulate the heat inside so it stays warm inside and the cold stays outside. They also have low melting and boiling points, so it's very easy to get them to melt or to get them to boil. So that is, I believe, all we have for covalent bonds today. I will link those other videos I want you guys to watch in our lecture as well. If you have any questions, please let me know.